exam question pattern is this one. So 3 questions. Each question carries 20 points. And the final like will be like total score is 60. And next is that 4 questions. Each question carry 10 points. So total is 40. Okay? Can you guess what are the 3 questions? Anyone? At least one question. SPM? Okay. These are the state. So how to construct a decision tree for classification using the given data and demonstrate how to build a decision tree using the provided example data. Explain the main idea of neural network based on the given data. So these 3 questions each carry 20 points. Okay? And the next 4 questions, describe the working principle behind the name layer. Highlight the key differences between random forest and extremely randomized tree. What the supervector machine and their advantage and disadvantage. Okay? So how many of you want to see this one? Last question. It's all about like how you are making it concise. Okay? It's up to you. Okay, but you should write very well. So now, in order to write very well, you have to understand the concept. Without concept, you cannot write. Okay? So let's revise like what we have seen for the classification. Okay? So I will point out like what are the information that should be presented in the answer sheet. Okay? So you should make a note of it. And you know, like after the final exam, don't come and ask me again and again. Okay? So can you memorize this data? Okay, I will provide you the data set. Okay? For example, if you look at so I will provide you this data for classification, this data for regression, and this one for artificial neural network. Okay? You don't need to memorize or you don't need to write by yourself. Okay? So I will provide this information. So using this information, you have to explain. Okay, so this is a given market, this is a training data set. So these are all your features. You have to write this a feature, this is a number of samples, and you are going to build a classification tree. The first thing is that you have to pick the feature that will go to the root node. Okay. So the thing is that there are several ways you can do. Like let's say like we are selecting popcorn, louse popcorn, and saying yes or no. So you are dividing into 2 leaves, and you can see like this side, like our left hand side, it has 1 3, and this has like a 2 1. Okay. So here, at least one leaf you have to provide the calculation. Okay. For example, like you have to provide the calculation at least for this louse popcorn. Okay, that is the most important thing. And this number should be consistent, okay? This should not be a random number. Okay, at least one. At least one feature, okay, you have to do the real calculation. Okay? This number, okay, it should be accurate. Okay, and this also should be accurate. Okay? And next is that, you know, your then first is Lowe's popcorn, right? Next is that Lowe's soda. I don't need, you know, the identical value. I don't need any calculation. You can give some random number. Okay? But the most important thing is that this should be like, you can see 0.214. So here it's like a, I don't know what it, how much it is, like Lowe's popcorn is like a 0.405. That's the total beginning impurity, right? And here, instead of 0.214, you can write like 0.395 or 0.4, it should be less than this number. Okay, it should be less than this number. Okay, you don't need to do any calculation here. Okay, no calculation. It means that like if you solve just only one, it means that you understand the concept. Okay, next one, put the random number. That random number should be less than the previous one. Okay, and next is that you have to do this one. Okay, because this is a continuous value. Okay, so you have to provide this equation. Okay, you have to provide like this equation, and you have to calculate the G impurity, and you have to write this also. Okay, and then next thing is that you don't need to do all those things. This one I don't need it. Okay, you just pick like a, greater than 15 or less than 15, or you can pick whatever value you want. Okay, just I want to see this one. Okay, using less than 9.5, you got this one. Okay, and I don't need anything like this. Okay, and you have to compare these three. Okay, so this calculation you have done. This calculation you have done. And this calculation I don't need, just random number. And make sure that this random number should be lower than these two. Okay, you should maintain the order. Okay? And then Lowe's soda will be your top node. Okay, that's a root node. And you have to make sure that these 4 data points should go here. You can highlight. Okay? And these 4 will be here. And you can mention that the remaining split will take place based on this value. Like you can see this exclude value. Okay? So these 3 will go here, and these 4. The remaining calculation will be happening on this node. Okay? And again, like this all is random. Okay? You don't need to do any calculation. No need to do any calculation. Just Lowe's popcorn. Gini impurity 0.25, you can say like 0.55. And age less than 12.5, you can see Gini impurity 0. Okay? This should be the like, you can say like a 0.15, something like that. Okay? And make the final tree. Okay? Any doubt? I'm not expecting you should write exactly what's in the slide. Okay? You should understand first. Okay, based on your understanding, you should show at least one feature how it can be calculated. Okay, if it is a discrete value, if it is a continuous value, how it should be calculated. That's it. And rest of them, if you understand the concept, you can write. Everything is like the random values. Okay, you don't need to memorize anything. With your understanding, you can write. Okay, and then. Yeah, so this is a final tree based on the data. Okay? And these numbers should be identical, okay? Because Lowe's sprawl, like it makes sense, right? Like 0, 1, 3, 0. So for example, like you are taking the 4 data points from here. You can see you are taking 4 data points from here, and you are again splitting into 5 data points. It doesn't make sense. Okay? It should be consistent. Okay, any doubt? Okay. Next is that regression tree. So these data I will give, okay? And the thing is that, see, we select the threshold that gives us the smallest SSR. So based on this one, you can see this is the drug dose, this is a drug effectiveness, and this is the optimal parameter, right? This is a 14.5, and you split into like average should go left hand side and this average should go right hand side, okay? I want at least one feature. You should tell how you extract these SSR, okay? So that's what like, yeah, you have to somehow, it's based on your understanding, you can draw. You can make the figure, okay? Based on your understanding. For example, like using this one, so you can say like a 3, and you can see like this SSR is like maybe like you can connect this figure, okay? And you can compute the SSR, and you can this one, okay? It's enough. And next is that you just put dot dot dot, like you don't need to show each and everything. No, I don't need this second point, third point, something like that. Okay? But somehow you have to connect these. Okay? I don't need this one. I don't need it. No need. Okay? This is fine. Okay? And after that, this is the first point, and this is the second point. So after that, you can directly go here. Okay? And show this is your lowest value, and the corresponding cutoff is here. That's it. Any doubt? Okay, this one, yeah, I don't need this one, yeah. Okay, so here, so based on dose less than 14.5, so again, like you are asking a couple of questions. So this thing not needed, not needed, not needed. Okay, so you will have like this one, like based on this 14.5, so 4.2% effective, and this is like the remaining percentage. This will be effective. Okay, and then no need. You just keep going. This is second column. Understand? I don't need anything here. No need. No need. Because my question is that based on the multidimensional data. Okay, not a single feature data. Single dimensional data, okay? Based on the multi-feature. So that's why I don't need this one. Okay? So here you have to show this is a regression tree, this is a multidimensional data. So using this multidimensional data, okay, so this is a multidimensional data, and first taking the first dose, you are getting the optimal value, and based on this optimal value, you are, dividing the tree, like making like a dose is less than 14.5. Yes means average equal to 4.2, and no means this average is equal to 51.2. And then you are showing your understanding about how you can derive this optimal value, how you are deriving this optimal value. Okay, that's what you have to make this one, and then first point and second point. Okay, and calculate the SSR and make this data point, and then okay, these are two data points. No. Okay, this is okay. Done. Okay, and after that you have to go to the second feature. Okay, you have to go to the second feature. Okay, in the second feature, you have to find the optimal value. Okay, make sure that you are making your data like making it at least a reasonable one. Okay, don't make a cutoff here, something like this. Okay, so you can see a clear separation. So make it this one and make this one. And then third feature is categorical value. So male, female, and again like this is yes or no. Okay, and compare these three features. Okay, you can see here the value here is SSR is much higher. Okay, so here is a lower. So this is the lowest one. Okay, and then this the lowest one will be the what? Root node. Okay, so you have to write it like that. If you write like if you mention this is the lowest value, and if you say like this will be your root node, I will reduce a point. Okay, there should be some consistency. Okay, and then this is like based on this one, like these two data points will go here, and these two data points will go here. Okay, and then you just say like next is like you can pick whatever you want. Okay, if you want to go sex here, age here, it's up to you. Okay, so construct the tree and show that like 0%, 5% something like that. You can change the value, no problem. Okay, so most important thing is that solving SSR based on the feature, single feature, and then showing the same thing for multiple feature, and then comparing, and then you are picking the best as the root node, and next what you are picking is important. Okay, so you can show like based on this data, like based on you can see here the next feature is the age and sex. It's done. Okay, any doubt? No doubt? Okay. So next is that neural network. I don't need this one. Okay. So the first one is that, so the main idea is that you have to fit the data. Okay. So this is the simple neural network. And you can fit the data. These data fitting can be either it's a green squiggle or red shape. Okay. So if you want to make this image, it's okay. And this I will give you. Okay, you don't need to worry about anything. So I will give you everything based on this, including these weight factor. Okay? And you have to write. Okay, you don't need to draw this figure, you have to write. So first, all the features should be normalized. Okay, because like you cannot use the same feature as such to the machine, input to the machine. Okay, that is the most important thing. Okay, including the objective value, and then you are taking the first dose and making the calculation, and this is the how you are calculating the soft function. You have to include the equation of the soft function. Okay, I will not give you the equation for soft function, and based on the soft function, so you will calculate the dose output. Okay, that is 0.2. Okay, and then you can see here, if you keep moving the, like you just like add like 1 or 2 points is enough. Okay, similar to SSR, just making 2 points is enough. After that, it's everything is a pictorial representation. Okay, how you can, you don't need to show like how it can be done for each data point. No, just do only one or something like a one, and then maybe second data point. If both are identical, just one and third. Okay, it's enough. After that, you are making this kind of green data point. This one I don't need it. Okay, you can directly go here. Okay, you will get a blue line, something like this, and then you are adding this value. Okay, as a result, what multiplying this value, negative value, your green curve, so blue curve will become something like this. Okay, you should show. Okay, how it. This is a new blue curve. Okay, and similarly for the below one, you will get again new curve, that is orange curve. Okay, if you multiply by some factor. If you look at here, multiplied by a positive value, so the curve is going much higher. Okay, and you have to just at least show like this is from upper hidden layer and this is from the lower hidden layer. Just mark it. Okay, and then make this one. This one I don't need it, so you can directly go here. Okay, you can directly go here and you can make a squiggle like this. Okay, and I will give you the value. This value will be there in the network. So using this value, you can make your squiggle something like this into this is your original squiggle. After adding the value, you can split your data something like this. Okay. Yeah. So it will be better like if you give some random dose and show the output. Okay. Any doubt? Okay. If there is no doubt, then the first 3 questions were done. So I will move to the next 3 questions. So what is the difference between random forest and extremely randomized tree? Okay, this is not as a feature what we are used to talk about. This is a characteristics. In terms of data sampling, random forest uses bootstrap sample with replacement for each tree. Okay. However, in the case of extra trees, they use entire original data set. In terms of split point selection, RF searches optimal split point among random subset of feature. See, you need to mention everything like this, all this one. Okay, so here you can say bootstrap sample for each tree. It's okay. You don't need to write everything. Uses bootstrap sample with replacement for each tree. No, bootstrap sample for each tree. It's okay. And here uses entire sample. That's it. Okay. And here it's optimal split point. So optimal split point among a random subset of feature. Okay. So here split point for each feature in a random subset. Okay. In terms of bias variance, so it has always a lower variance than a single Asian tree because bagging and feature randomness. You have to say a lower variance because of bagging and feature randomness. Okay, if you write this, it will be enough. Low variance because of bagging and feature randomness. However, here, so here like a much even lower variance because due to increased randomization. Okay, but potentially it's like a higher bias in this case. So you have to write this one. And in terms of computation speed, okay, so this is a slower because it has to find optimal split at each node. Okay, so you can mention like it's slower, it's enough. And this one is faster because it avoids the computationally intensive search to find the best split at each node. Okay, and in terms of overfitting, this is a less prone to overfitting than a single Asian tree, and this is a more robust, okay, to overfitting due to enhanced randomization. Okay, so just have a look at it and highlight the important points. Just don't write like a single word and come and ask me, please give me full points. No. Okay. Any doubt? Okay. So next is that support vector machine. So support vector machine is a supervised machine learning algorithm. So it can be used for both classification and regression. And you can see here the data points. Okay. So you can see this is one class and this is another class. Okay. A point which is near to these hyperplane are called support vectors. Okay. In SVM algorithm, we plot each item as a point. Okay, even though like a multi-dimensional data doesn't matter, just one point. Okay, with the value of each feature being the value of a particular coordinate, and then we perform these kind of separation. And next is that what are the advantages of SVM? Actually, it works really well when there is a clear separation between data points. For example, like if you look at the map, you can see like a different clusters, right? So if you use those, if it has a label, if you use that data as an input to the support data machine, this perform really well. Okay, and this is more effective in high dimensional space, and it's very effective in when the dimension is greater than the number of samples. What does it mean? Okay, anyone understand this one? So the number of samples is 10. Okay, the feature dimension is 60,000, 50,000, whatever it is. So still, like this is very effective. SVM is very effective. Okay, and it's relatively memory efficient. And in the case of disadvantage, it has two major constraints. It works very well with real number or integer. Okay, because all the data points in the feature should be mentioned numerical value only. And it works for binary classification. It doesn't support multi-class classification. Okay, and when the data set is large, okay, like currently we are running deep learning algorithm, so it does to handle a large data set. But like SVM, you cannot handle large data set. If it is like more than 10,000 samples or 10,000 data points, so this is very slow. Okay, even a single model will take more than a month. Okay, so that's why it's inefficient and time consuming. Next is that it does not work well when there is too much noise in the data. In this case, like deep learning perform much better. Okay, and as a support vector classifier works by putting data point, just like putting all your data point above and above below and making a hyperplane. Okay, but there is no probabilistic explanation for the classification. Okay, how it can be done. Okay, so that's the disadvantages of support vector machine. Okay, and next is that name layers. Okay, so name layers like you can you can directly go here and you can show like a couple of emails, and this is your normal and spam, and then from here you can skip this, yeah, you can directly go here, or like maybe you can go here, yeah, this will be better. Okay, so you can directly explain like a multi-nominal name layers. So you can start with the training data, and then this is a normal, and this is a spam, and you can make a word, okay, and you have to construct the histogram. Okay, so here like everything like you can do it like based on your imagination. So I will not check anything like here you can write whatever you want. Okay, right? This histogram is not be consistent. Okay, this can be much higher than this one. Okay, or this may be like higher than this one. Okay, it's up to you. But based on these, whatever the histogram you are calculating, so you have to make this equation and you have to do all this calculation. Okay, so probability of word here in normal, the probability of friend, whatever number you are writing, in normal. Okay, so if you look at here, like it's 0.47, and rest of them is like the less value. Here you don't need to calculate everything, like you just like make it a random number. And in this case, like you can see, this is 0.29, and money is like a much higher value. Okay, you should show at least like a one value. Here is like extreme value in the normal and lower in the extreme value in the spam. Okay? So remaining like you can change. Okay, everything like you can write a random number, no problem. Okay? And then you can see so here. Okay? So for example, like you can see here like they're comparing like the probability of normal and total probability. Like you can see this is higher than this one. Okay? So you should show these things. And then okay, any messages like it's comparing like the probability of like calculating this probability and mention this value. Okay. Yeah, it will be directly go here. Yeah, this also good. You can directly start from here and explain each and everything. Okay, and you can go to this one. And then, for example, like if something is coming, like you can see here, okay, and you can mention that like this kind of missing data will be done by, adding pseudocounts. Okay, finish it here. Okay, don't need to do, again calculation. Okay, just add pseudocounts, finish it there. Okay. Any doubt? So this one I don't need it. Yeah, just leave it. The add pseudocount is done. Okay, last question is like it's up to you. Like whatever you think about this class, you can write. So you are free to write. Okay. So that's the end of today's class. All the best for your exams. Okay.